probability that a read present is selected is 5/12. Find the value of H. Okay, so the last time I said that probability, the value itself, the fraction itself, it is actually proportionate to the entire situation. So therefore, right, since there are 25 read presents, okay, the probability of choosing a read present will be 25 over the total number of presents, right? So what is the total number of presents? What is the total number of presents? How can I express it into an expression? 25 plus H, good. Okay, so this will be the probability of getting a read present. Okay, and now in the question it says that it is 5/12. So the fraction here will simplify to 5/12. It doesn't matter, okay, whether the original before it gets simplified, what exactly it is. Okay, because I can always just cross multiply, alright? Okay, and I solve for H. Okay, because the two fractions have to be equal. Okay, it's just like, for example, if I have 2/7, it is equals to 4/14. Alright, so in this case, I'm just writing two fractions that are equal to each other. Okay, then after that, I will solve. 25 times 4, what is it? 25. 300. So 300 equals to 50, 135. Okay, so we just solve now. And then this one will be 175. 35, right? So H should be equal to 35. Then next, when it comes to part B, okay, they give you the probability of a white present instead. Okay? So there are two ways that you can do. Either, alright, in part A, all we did was to find out probability of red present, and this is the probability of red present also. Okay? In part B, we are instead given the probability of white present. Which is 3/8. Okay? You may choose to find out what is the probability of red present, which is possible. Okay? Or you continue to use the probability of white present. So if I want to make use of the probability of red present only, if I know white present is 3/8, what is the probability of red present? What would it be? 1 minus 3/8. So that's 5/8. Okay, then just now I already know red present is this fraction. So 25/25 plus H equals to 5/8. Then it's the same process. Okay, I'll leave it to yourself to complete the question and write the answer. Okay. Next, question 9. It says that a carton contains 15 toothbrushes, of which X have soft bristles. Write down an expression terms of X for the probability that a toothbrush selected at random has soft bristles. So what would the probability be? We got X number that are soft bristles. Total is 15. So answer will be what? X over 15. Then next, part 2. When 5 more toothbrushes with soft bristles are added to the carton, the probability of drawing one with soft bristles at random becomes 3/4. So now, right, okay, total toothbrushes originally is 15. Soft bristles is X. Okay, but the question says now add in 5 more change to become 15 plus 5, right? So it is becoming 20. Okay? And then the question now says that the probability of drawing soft missile is 3/4. So x plus 5 over 20 is equals to 3/4, just like how we did in question 8. Then we cross multiply and solve for the value of x. Okay, so I'll leave the solving to you. To treat osteoporosis, the probability of randomly selecting a patient with no change in bone mass density is 7/13. Okay, so let me just write down those information. No change is 7/13. Then after that it says that 1/x of the patients had a slight decrease in bone mass density and the remaining 1/2x of them have found to be significant reduction. Okay, so probability with slight decrease is 1/x. Because the fraction of patients, right? Okay, the number of patients, the fraction itself, right, is actually the same as the probability fraction also. Okay, then the remaining 1/2x have found to be significant reduction. Okay, so these are the 3 cases that can happen. Right? Understanding probability itself, what should the probability over here all add up to become? 1. Okay, so that's how we form our equation. 7/13 plus 1/x plus 1/2x equals to 1. Our problem is how to solve. I'm asking you, what have we learned about solving fractional equation? Fraction, add fraction, add fraction. We must have same one. Denominator, right? Okay, so what is the same denominator that we will look for? 13? Or x, or 2x, or something else. 26 then the x no need Okay, we will look for 13 times 2, 26, and we'll keep the x. In order to have 26x, right? Okay, 13 to get 26x, I'm looking at multiplying 2x to the denominator. Correct? In order to have 13 to become 26x, I multiply 2x. So on top here, I multiply 2x also. So I will have 14x as a result from the first fraction. Then in the second fraction, to get 26x from x, I need to multiply by 26, multiply by 26. So I plus 26. Whereas the last one, to have 2x, to get 26x from 2x, I need to multiply by 13, multiply by 13. So I will plus 13 equals to 1. Okay? Then after that, I simplify the numerator, so 14x plus 39 over 26x equals to 1. 1 means 1/1, so I cross multiply. Okay, 14x plus 39 equals to 26x. Right? Then solve. 39 is equals to 26x minus 14x equals to 12x. See? Okay, hang on. Can I do some more calculations on it? Question 10. Then is 3 and 1 quarter. Oh, okay. X is not number of people. Okay. X equals to 29 divided by 12. So 3 and 3 and over 12, 1 quarter, right? Okay, because X is just a number. Okay, it is possible. So the probability of slight decrease will be 1 divided by 3 and 1 quarter. Then you can find the fraction to become divided by 3, 4 over 13. Yeah. Last one, question 11. There are 23 boys and 35 girls on the school's track and field team. Okay, so we write it down, 25 boys, 35 girls. At the end of this year, X boys and X plus 4 girls will graduate. So when they graduate, does it add to the number of boys and girls, or does it minus away from the boys and girls? Minus, right? So when they graduate, the boys will minus by X, girls will be minus by X plus 4. Okay, then I'll write down an expression in terms of X for number of boys left in the team. So how many boys are there left in the team? How many boys would there be? Sorry? 25 minus X. And the number of girls left? Oh, 23. Sorry, I read wrong. 23. In the team. So that will be 35 minus away X plus 4. Okay, please simplify this. Open up the brackets, 35 minus X minus 4. We get 31 minus X number of girls. Part 3, total number of boys and girls left. We just add these two up. 23 minus X plus 31 minus X. You may put brackets, although it doesn't make a difference. Okay, because after you open up the brackets, it remains the same. So we get 54 minus 2x. Then in part B, it says that the probability of selecting a boy at random for an event becomes 2 over 5. So the probability of selecting is 2 over 5. Find the value of X. So how will we express in terms of X the probability of selecting a boy? What will the probability of selecting a boy be, Aishan? In terms of X. Sorry? Yeah, so I'm not asking you. You don't expect me to feel you answer. In the exam, I will not be there. Aishan, the answer is 25 over X. No. So think. What is the probability in terms of X for selecting a boy? I already did 3 examples all the same time. 23 minus X over. See, you know how to do, you just want to use your brain. Okay, 23 minus X over 54 minus 2X. Okay, and that is equals to the probability given in the question, that is 2 over 5. Okay, then we cross multiply. Okay, and then solve. Okay, I will leave the solving to yourself to do. I'm sure you are skilled in solving algebra questions. area of pyramids, cones, and spheres. Okay, do you know pyramids, cones, and spheres? Shapes. Yeah, not shapes. Shapes are 2D one. Yeah, just figures, solids. Okay. Right. Okay. So we're going to be looking at this chapter, and we will study the volume and surface area, okay, of these three main figures here. Right. Last year we studied about cubes, cuboids, cylinders. Okay. Anything that is prism. Okay. Prisms. Alright. If you forgot about it already. Prisms. Okay. Prisms are things that are actually of the same shape throughout the whole 3D figure. For example, if you imagine my water bottle, if you cut off the top part, from here all the way to here, it is the same throughout. It is a cylinder shape. Okay. Whereas for pyramids, cones and spheres, right? Okay, this is an example of a pyramid. Right? So something that you're familiar with in terms of in Egypt itself, okay, they are the square base or rectangular base kind. So it's not the same throughout. Okay, so throughout the whole thing, it is not the same size square, okay, for every single layer. Even for the triangle, so it's not the same triangle if I were to slice it, okay? Then another kind of pyramid is where it is a triangular base. Okay, so the base bottom part is a triangle. Okay, so it is not the same throughout also. Then we have the cone. Okay, we have the cone, which is circular at the bottom. It looks something similar to my prism actually. Just that for a cone, it is actually circular. So actually circle figures, okay, circle shapes, they are actually infinite number of sides. There are many very small size. Okay, as compared to a square that is actually a fixed four-sided figure. Then after that we have the sphere, which you will call a ball. Okay, but then for sphere, in maths we call it a sphere. Okay, to be specific. Right? I'm not able to bring in the water into class. Okay, because this water here is my drinking water. Right? I'm going to show you how we get the formula for the volume of pyramids, cones, and spheres. So in your notes, okay, you will find that the formula appears on page 2. Okay, so I hope that you will do some form of highlighting. Okay, page 2. Alright, you have your volume of pyramid. Alright, and then after that, the formula is 1/3 times base area times height. Then after that, on page 4, we have volume of cone, which is 1/3 times pi r squared times height. Whereas pi r squared is the formula for what? Formula of what? Pi r squared. Area of circle, right? Okay, so it's the base area of circle. And then after that, on page 6, we have volume of sphere, which is 4/3 pi r cubed. Okay, so we got these three formulas going on, and you've got to remember them. Okay, but the problem is we need to have better memory of this. Okay, it is easier to understand why is it that there's such a formula. Okay, to understand why is there such a formula, okay, it is going to write on certain basic figures that we have already learned. Okay, in set 1, those are your prisms. Okay, so I'm going to show you the video now for the pyramids part. Okay, let me select this one.
A-based pyramid. This is a cube, and this a square-based pyramid. The base area of this square-based
Sorry.
is the height of the square-based pyramid is also the same as the height of this cube. Will their volume be the same? Let's compare.
think volume will be the same? Of course not, right? Okay, so let's just make a guess. Volume of this pyramid versus this volume of the cube. Okay, same height, and the base also exactly the same. Alright? How many times more? Okay, which one has more volume? Which one do you think?
The square one.
Who thinks the cube will have more volume, right? Okay, yes, that one will have more volume. But how many times more? Who says 2 times more? Who says 3 times more? Who don't dare to make a guess? Just guess only, no harm, right? Okay, so let's see.
Let's fill the square-based pyramid with water to the brim. The amount of water represents the volume of the pyramid. Next, we pour the water into the cube. We can see that the water does not fill up the cube.
So this is obvious, it's not the same volume.
Let's use this square-based pyramid to pour more water into this cube until it is completely filled. This is the second time. And the third time. After 3 rounds, the cube is completely filled with water. The volume of 3 square-based pyramids is equal to the volume of the cube.
So you see, okay, after pouring the water, we notice that 3 times of the pyramid is equals to the cube itself. So,
having the same height and base area.
Therefore, 1/3 times volume of cube is the formula.
Since the volume of the cube equals base area times height, the volume of the square-based pyramid is therefore 1/3 base area times height.
Okay, so that is the reason why, okay, our formula for volume of a pyramid, right, is actually 1/3 because it is 1/3 of a full cube itself, and the cube has the formula for volume to be base area times height. Okay, length times breadth times height. Right? That's what we learned about cubes. Okay, for volume of cubes, we learn length times breadth times height. Which length times breadth gives us the area of the base. Okay, so that is the reason for such a formula. Okay, so I hope that you can remember by that. Okay, it doesn't matter that in the end, if my pyramid itself, okay, if the bottom, the base part, if it is not a square, even if it is a rectangle, or in this case, a triangle, okay, let me put this back. Even if it's a triangle, okay, it will still be 1/3, okay, times the base area, the bottom area, and the height. Okay, so that is the reason for pyramids. Now let's take a look at cones.
Volume of a cone. This is a cylinder. The base is a circle, and this is the height of the cylinder. Do you remember the formula for the volume of a cylinder? Is it...
What's the volume of cylinder?
Pi r square times h.
Pi r square times h. Because if I got a cube, it is base area times height. For cylinder, it's just that the bottom part, instead of being a square, it is a circle. So the area of circle is pi r square, okay, then times the height. So it's actually the same formula for cube and cylinder. In case you don't realize it, okay, I said last year, by the way, right? In case you forgot, right? I need you to realize that actually they are all similar looking, okay? Just that the bottom part is the determining factor to make the difference. Okay, so pi r squared times height.
Base area times height, which is pi r square h. We have a cone here. The base area is the same as the base area of this cylinder. They have the same height too. Will they have the same volume? Let us find out.
So I think we are all convinced that they can't have the same volume.
Let's fill this cone to the brim with water. The amount of water represents the volume of the cone. Now, let's pour the water into this cylinder. we can see that the water cannot fill up the cylinder. The volume of this cone is less than the volume of this cylinder. Let's use this cone to pour more water into this cylinder until it is completely filled. This is the second time and the third time. After 3 rounds, the cylinder is completely filled with water. What does this mean? The volume of 3 cones is equal to the volume of 1 cylinder. Remember, the volume of a cylinder is pi r square h. Therefore, the volume of the cone equals 1/3 pi r square h.
Okay, so I hope you realize, right, that in the formula for the cone, okay, 1/3 times what? 1/3 times the volume of a cylinder actually. So this one is your your cuboid, okay, or any other prism actually. Alright, and this one specifically, we're matching it to a cylinder. Okay, then after that, for sphere, okay, it doesn't seem very clear, okay, that it is 4/3 pi r cube. So how did we get that formula? Okay, so let me play this video.
We have a cone and a sphere. Can you see that the height of the cone is the same as the diameter of the sphere? And the diameter of the base of the cone is also the same as the diameter of the sphere. But which one has the larger volume? Let us find out. Let's fill the cone to the brim with water. The amount of water represents the volume of the cone. Next, we pour the water into the sphere.
How much do you think you'll fill? Half, okay.
We can see that this amount of water can only fill the sphere partially. Let us pour water from the cone into the sphere again. The water fills up the sphere after the second time.
Perfectly filled up.
So, the volume of 2 cones is equal to the volume of the sphere. We have learned that the volume of a cone is 1/3 base area times height. Note that the height of the cone is the same as the diameter of the sphere. And the base area of the cone is pi r squared. Therefore, the volume of a cone is equal to 2/3 pi r cubed.
Okay, in this part over here, because we know that volume of cone is 1/3 times pi r squared times height. Okay, but usually in the question, I will just give you a sphere, I don't give you a cone. So I wouldn't know, okay, exactly what is the height, okay, the h that's referring to if I want to use such a formula. Okay, so what I need to do is I change the height to something that's in terms of r. Okay, and we find that the height of the cone is actually 2 times, or rather the diameter, so-called, of the sphere itself. So therefore, we change the height portion into 2r. And upon simplifying it, we get volume of cone to be 2/3 pi r cubed. Please don't confuse yourself to think that volume of cone is going to be this formula. We usually stick with this one, okay, because I will usually give you the height instead of just having the radius. Okay, then
Remember, the volume of the sphere is equal to the volume of 2 cones. Therefore, the volume of a sphere is equal to 4/3 pi r cubed.
Okay, so therefore we get volume of sphere to be 4/3 pi r cubed. Okay, volume of a cone is never going to be 2/3 pi r cubed. The reason is because it is not all the time that the height of my cone, okay, it is not all the time that the height of my cone is actually 2 times the radius. Because I can always have a longer cone, right? Okay, so for example, the ones that you see in PE, the longer cones, surely with that height, it can't be 2 times that small radius. Alright, so it is not all the time that volume of cone goes by this formula. Okay, it is just in this particular case only. Okay, so don't confuse yourself. So we will go by this 3 formula in terms of finding the volume, okay, for these 3 solids. Right? Now let's get back to our notes. Okay, so let me unplug this. Okay, so in your notes itself, today we're looking at pyramids first. Okay. Okay, so for pyramids, okay, pyramid is a solid, okay, in which one of the surface is a polygonal faces, okay, a base. So in the first page itself, you will see different types of pyramids, okay, with different kind of base. A right pyramid, okay, is something such that for the base part, the top, okay, this is what we call the vertex, okay, the corner. So the vertex is actually directly from the center goes all the way up. If this part at the top is slanted another way, then it is no longer called a right pyramid, okay? It is not called a left pyramid, okay? It is just not called a right pyramid. Otherwise, it's called oblique pyramid actually. Okay, it's inside your notes. Although we will not be mentioning that kind of pyramids. So the perpendicular height, okay, I want you to be careful that the perpendicular height of a pyramid itself, right? Okay, in a pyramid, perpendicular height is from the top part all the way to the center of the base. So in this case, assuming that this is a square base or a rectangular base, it doesn't quite matter. But this thing here is what we call the height. Okay, and then after that, the slant height itself, okay, which is another important term that we must know, right, is that okay, slant height is along the triangle. Okay, along the triangle. Right? So you have this triangle here. It's right in the center down. Okay? This length down here is not the same as this length here. Okay? If you don't believe, then maybe you do some demonstration. You measure. Okay, I want you to measure right in the center of the triangle and at the side of the triangle. Okay. Just measure. Put your ruler against it. Okay, verify to everyone as I take show at it that they are different. The center line along the triangle and at the corner over here, okay, are they of different lengths? Yes, they are of different lengths, verified by our Professor Devon. Okay, so this thing here is what we call the slant height. Okay, and the purple one here is called the slant edge. In our calculations, we will usually use slant height, okay, and we will use height. Alright, then of course in this case we have the length and the breadth. Okay, depending on what kind of shape is at the bottom, of course. Okay, so at the top here, sorry, I just not say wrongly. This is called apex, not vertex. Okay. Okay, so that's the highest point, so apex. So we will use height, slant height, length, breadth in terms of the calculation for volume as well as the calculation for total surface area. Those people who want to sleep, I invite you to go outside and sleep this. Want to continue sleeping? You can make this permanently your home. Next year you will still see it. Okay? So let's look at example 1. Okay, but we'll find out volume first before we talk about surface area. So the volume of this pyramid given in the question, we got something like that. Okay, the height itself is 9 cm. length 8 cm, breadth 6 cm. Okay, we want to find the volume. So how to find the volume? Volume equals to what? Hayward, earn your right to go toilet. How to find the volume? Yeah, you know who with you. Volume equals to? Yeah, so how does that fall into place? What's my calculation going to be? 1/3 times what? 8 times 6. That's all. Times 9. Okay? Equals to 144 cm cube. You copy, finish first, then you can go toilet. Example 2. Right? We are given this pyramid and the volume is 48 cm cube. I want to find in this case the height Vn here. So how do you think we can find the height? Ben, what do you think? How to find the height? I got volume, I got 6 cm, 4 cm, how to find the height? 48 divided by, sorry, 1/3 and then divided by, I can't hear, sorry. 48 divided by 1/3 divided by 24. Okay, how do you get 24? Sorry, 6 times 4. Okay, so the reason is because our volume, we know that it is 48. And that is calculated by having 1/3 times 6 times 4 times the height Vn. Okay, I noticed that in your WA3, many of you are not used to using the letters that are given. You like to always say, let Vn equals to x. Okay, that's unnecessary. We know that this thing is actually just called Vn, that's all. Right? Don't need to go and introduce another letter inside it. And then you confuse yourself, or sometimes may confuse the invigilator or the examiner. Okay, so therefore, to find out what is Vn, we will take 48, divide by 1/3, divide by 6, divide by 4. Okay, so everything moves to the left, okay, or rather so that we get 4 in this calculation here. And then we find that Vn will be equals to 6 cm. Okay? Example 3. The diagram in your paper is definitely much clearer, right? In this question, they gave you the height Vn is 8 cm, the length AB is 12, okay, and find the volume of the square pyramid. The question specifically say square pyramid. So you're going to be able to recognize what a square pyramid is. Okay? A square pyramid doesn't mean that all sides are square. If all sides are square, it's called a cube. Okay? So a square pyramid is when the base itself, okay, is a square. So what this means for us is that if I know AB is 12 cm, then the length of BC, what would it be? 12 also. Okay, so that is the information that you need in order to find the volume, because volume is 1/3 base area times the height. Right? So my calculations will be 1/3 times 12 times 12 times 8. And I have 384 cm3. Okay? Now let's progressively go into talking about slant height, okay, which is going to be used in surface area later on. Okay, so the slant height in this question is actually referring to this side DM here. Okay, which is what we want to find in part B. Okay, part B we want to find DM. It is the slant height of the pyramid. Okay, so slant height, let me add on this information here. So slant height of pyramid, but it is actually also called the height of the triangle. Okay, so it is slant height of pyramid and also height of the triangle. Right, so they mean a different thing. Okay, so in this case they want to find the height of this triangle, which is also referring to the slant height of the pyramid. So now how do we find the slant height then? This green one. Yes, Chpt. The base of the slant height. You mean this one here? This one here. MN is 6. How do you know it's 6? Okay, so we're going to notice that for a right pyramid, when I have it from the top going all the way down, it is right in the center. Okay, so it is of the same distance here and also the same distance here. Okay, so this thing is actually half of this and this part here is half of this. But these two might not be the same. It is only the same if the base is a square. If it is rectangle, then surely this part might be longer than this one. Okay, but you must know this one is half of AB and over here is half of BC. Okay, so what we will focus on is to focus on this right angle triangle over here. Okay, so this is going to test on your visualization of the pyramid. Okay, so looking at that right angle triangle, if I bring that out, okay, this is N, this is B, this is M. So just now what Chpt said is that NM is actually 12 divided by 2. That is 6 cm. Okay, and in the question, VM is 8 cm. I am trying to find out what is VM. Okay, Pythagoras theorem will help us to find VM square equals to 8 square plus 6 square. Okay, and that will give us 100. So VM is square root 100 or negative square root 100. But we know it cannot be negative. So VM is 10 cm. Yes, Lisa. Can VBM? Yes, you can do Pythagoras for VBM, but how will you want to do it? I find the length of BC. BC, okay, then you find this one. Then, how to find VM if I don't know what is VB? Okay, so, alright, means that what Lisa said, it seems is true, it's logical. I can do Pythagoras, okay, on the triangle found here. Okay, it is actually the slanted triangle. Where's my pyramid? Okay, so he is actually saying, if I have my pyramid here, I'm trying to find, I hope can erase, let me try. Okay. Okay, so we are trying to find this length here. Okay, so just now in my working, I'm finding the triangle, right angle triangle that's inside. Okay, inside going down from here in the middle, and then after that to this length here. Okay, but what Victor is saying is that to find out what is this, he wants to use the one on the surface, this one here. Okay, do you all see it? Can see, right? Okay, so if I want to find out what is this part, okay, and I can find out what is this, which he said was 12 cm divided by 2. So down here is 6, no, it is true. But I don't know what is this length one. I don't know what is this. So because I don't know what is this one, and this part just now, Declan already said, this side and this side not the same. Okay, so there is no way, alright, for us to go and calculate using Pythagoras theorem using this triangle.